Hi everyone, my name is Meagan Cojocar and I'm a product manager here at Pulumi. Today I'm going to be talking to you all about how our enterprises are using Pulumi and the key functionality that they're leveraging. Kind of giving you a bit of info into what our customers tell us and what kind of use cases that they're using. I'm going to wrap up with a demo of one of these features because no one likes just corporate talk and slides. Let's get into it and get our hands dirty. Okay, so let's talk about who these enterprise customers are. Now, obviously, not all of our customers have consented for us to use their name publicly, but we have a subset of customers who have. These are kind of like the key ones that you might recognize. We're really grateful to work with large enterprises and well-established enterprises such as Snowflake, Atlassian, Mercedes-Benz, in addition to the rapidly growing cohort of enterprises around the world who are now depending on Pulumi's cloud engineering platform. These customers use Pulumi to enable modern cloud transformation, accelerate their developer velocity, and adopt the most rigorous security and compliance requirements. We've seen remarkable growth within this cohort. We recently announced that we have 350% year-over-year growth in the number of enterprise customers that are using Pulumi. So there's a lot to be excited about in this space. Now let's talk about why enterprises are using Pulumi. So we're going to talk to like a handful of features, like maybe 10 features that Pulumi has, and give you info about it in the specific context of enterprises. Multi-cloud enterprises are using Pulumi so that they can have consistent and cloud agnostic infrastructure as code. So instead of relying on cloud-specific definition files, they use Pulumi to manage all modern cloud workloads, such as containers, Kubernetes, serverless, and so on. Using one infrastructure as cloud platform across multiple clouds helps to tame the complexity of multi-cloud hosting. It makes it easier to maintain consistent workflows and standard practices across multiple clouds, and it allows our customers to reduce their lock-in. By having one cloud engineering platform that supports multiple cloud providers, enterprises are more flexible and agile to use the right cloud native service for the job or for whatever tool they need. They don't have to be constrained by what infrastructure as code platform they're using. But the benefits of Pulumi doesn't stop at just the provisioning and managing of resources, whether that's in one or multiple cloud environments. It also extends to deployment. And so enterprises are building their entire CI/CD pipeline, continuous integration and continuous deployment with Pulumi baked into the process. And so infrastructure changes can be reviewed, validated, tested, as any application code would be. And some examples of this is you can do code reviews using pull requests on your infrastructure changes. You can run the code through linters and static analysis tools. You can use unit integration tests. So essentially bringing all of the power and benefit of software engineering to your deployment as well. And it all just works for your cloud infrastructure in the same way that it would for your application code, which reduces errors, improves security, and once again, increases your delivery rate. Not to mention your application developers are used to these tools. It's familiar to these processes. Instead of having this bespoke process just for infrastructure and the learning curve that comes along with it. So this is a fan favorite that our enterprise customers like to talk to us about, which is policy as code. So policy as code is a way to design and enforce what you can and can't do within your organization. And you do this through having a series of rules or procedures. Within the Pulumi Cloud Engineering Platform, our policy as code tool is called Crossguard. And Crossguard empowers you to use a set of guardrails to enforce compliance for resources so that developers in your organizations can provision their own resources and stick to your best practices and meet security and compliance. Basically, the same benefits that we were just talking about in terms of bringing software engineering to your CI/CD processes applies for policy as code. So you're writing these policies in familiar programming languages and can manage them as such. So using policy as code, you get to define your business logic in a flexible way and then run these policies on demand. You can have scheduled reports based on the policies. And you can also have your deployments gated by these policies. So organization admins can apply these rules to a particular stack or to the entire organization. And these policies are executed as part of your Pulumi deployment. And any violation can gate or block that update from proceeding. So with Crossguard, policies can be defined as advisory, mandatory, or disabled. And so in the case, a very common use case that enterprises are using this for is having a advisory policy for your non-production environments, your dev, staging, test, sandbox, etc. And then essentially when a developer goes to deploy within these environments with these policies, they'll receive a warning if the policies have not been met, but the deployment will still carry out. Whereas in production, you can set the policies to mandatory, meaning that the deployment will fail when the policy is not met. And so this is a good way of educating on company policies without slowing down any developer productivity or like just adding barriers to deploying things. I am planning to demo a simple policy as code use case at the end of my presentation, so stay tuned for that. We'll make it fun and interactive, and you'll kind of know what I'm talking about in practice. So Pulumi stores metadata about your infrastructure so that it can manage your cloud resources. This metadata is called state. Each stack has its own state, and state is how Pulumi knows when and how to create, read, delete, update, etc. your cloud resources. You can store your infrastructure state for any cloud in Pulumi's secure backend, which has built-in scaling, availability, fault tolerance, or you can self-manage your state yourself. Your infrastructure state is encrypted in transit and at rest. When state is all in one place, you can take better advantage of stack references, deploy in parallel with concurrent state locking and audit changes, or roll back to previous versions of your state. All resource input and output values are recorded as state and are stored in the Pulumi service or in a file or a pluggable service provider that you choose. These raw values are usually just server names, configuration settings, and so on. But in some cases, however, these values contain sensitive data, such as database passwords or service tokens. All Pulumi editions offer secret management features, and this is something that our enterprises frequently talk to us about being a value add. If you look in our case study with Snowflake, you'll see that they talk about how they leverage secrets management within Pulumi. And so our secrets management stores encrypted data used in the configuration of cloud resources. This encryption is in addition to the encryption in transit and rest with state that I described before. This ensures that certain data elements are not shown in plain text in Pulumi's command line interface, CLI, or in our service console, and they're not emitted as plain text in any of our Pulumi serialization formats, such as JSON. Pulumi ensures that secrets are encrypted deeply, so any secrets supplied during the construction of resources, input or output properties remain encrypted. So this might happen, for example, if you provision a cloud managed database, such as Aurora MySQL, or a SaaS service token for your serverless function. And so as these, in the construction of these resources, these secrets are encrypted. During the Pulumi service, you can utilize built-in secrets management, or you can bring your own secrets manager. So we have support for AWS. Well, you can bring your own secrets manager. The common ones that are being used by enterprise customers is AWS KMS, which is Key Management Service, Azure Key Vault, Google KMS, and HashiCorp Vault. It's important to note that your cloud access keys are never sent to the Pulumi hosted backend, as all cloud API interaction is done at the Pulumi client or CLI level. Now let's talk about RBAC. So another core feature our enterprises are utilizing is role-based access control. So role-based access control may be configured at either the organization level or at the individual stacks within the Pulumi service. If set at organizational level, these stacks inherit the permissions unless they're otherwise overridden. The Pulumi service permits using RBAC or role-based access control within teams, and teams allow organization admins to assign a set of stack permissions to a group of users, and these stack permissions can be one of 4 permission levels. 1, there's no permission, the user can't read or write. 2, they just have read-only permission, 3, they can read, write to the stack, or lastly, they have admin permissions for that stack. As you can imagine, a lot of enterprises are leveraging this to empower them to follow the principle of least privilege. And therefore they can ship faster with more confidence. And an example of the use case for this would be that you have all of your developers having access to your dev stack, but in production, for whatever workload that may be, only your person responsible for DevOps or on your infrastructure or platform team has the access to actually read, write, or admin access on that stack. User identity for the purposes of RBAC may be backed by any other given identity providers, or you can manage it manually. So something that comes up a lot with our enterprise customers is security. We recently published a security white paper, which if you're interested in, you can check out at pulumi.com/security and learn more about what we do here. But to kind of touch on some of the cliff notes, we do not host any servers ourselves. Our architecture follows industry best practices, and Pulumi is a certified AWS advanced partner, which entails thorough security architecture review and audit with the AWS team. We also perform annual penetration testing of our service and application and maintain an active SOC 2 Type 2 compliance. The Pulumi service has audit logs to help you track the activity of users within an organization. They attempt to answer what the user did, when they did it, and where. This helps in answering these questions. We help in answering these questions by recording all of the user's actions. And these logs are immutable. It makes the activity of members in an organization attributable. The logs capture the Unix timestamp, the user who invoked the action, the event that took place, the source IP of the call the user made. Our enterprise customers tell us that these logs come in handy when there's an incident with the deployment. Let's say there's errors with deployment, or a bug was pushed to production, or whatever it may be, and they need to investigate. And so if you're having like a post-mortem of what happened or a retro, you can basically go back and track what happened and have all of this metadata. Audit logs can also support like compliance requirements that enterprises have to meet, whether that's their internal compliance requirements or something that's mandated by larger compliance regimes. Audit logs can be programmatically exported on an automated schedule for enterprises who are on the business critical edition. So you can have your audit logs being exported outside to, let's say, an S3 bucket. And so let's talk about access, the third pillar on this slide. So there's a lot of cloud applications and service providers. And so using single sign-on with SAML is a way to make it easier for organizations to manage access for their employees. In addition, if an employee leaves, if an employee joins, like all of these things can be done at scale a lot easier than having a bespoke sign-up process. The Pulumi service can be configured to work with SAML 2.0 identity provider, with any 2.0 SAML identity provider. So some common ones here would be the Azure Active Directory, G Suite, Okta, etc. And Pulumi Service also supports cross-domain identity management, also known as SCIM 2.0 integration with different identity providers. And the benefit of this is it enables you to synchronize your identity provider with your Pulumi users, which once again are just things that enterprise who have a lot of users using Pulumi take advantage of, so that they don't have to manually update each application and service provider separately. So there's two ways to use the Pulumi service. One, managed, which is definitely the most common use case, or self-hosted. The managed environment is highly available and it's hosted across multiple cloud regions and availability zones. It runs in Docker behind an AWS VPC with all the network comms encrypted using TLS, and endpoints are only accessible using HTTPS. There's no connectivity from Pulumi.com to your cloud environment. Pulumi has none of your cloud credentials, which I mentioned previously. Your resources are run strictly within your cloud. And lastly, as I mentioned before, the Pulumi service handles robust state and lock management on your behalf. Some of our large enterprise customers have compliance requirements where they need to self-host the Pulumi service. And in the self-hosted edition, which is available on our business critical edition, the same highly available architecture is available with more control over your hosting options, your network isolation, data ownership, and identity. So hosting options include public, private, and hybrid scenarios. The self-hosted business critical edition does not communicate outside your private network, including with Pulumi.com. The client may be run within your private network to eliminate all communication over the internet altogether. Okay, the last thing we're going to talk about before we jump into a demo is the migration tools that are available. So at Pulumi, we understand that cloud engineers and platform teams don't have the luxury of building greenfield projects for everything. More often than not, we're stuck with the impossible task of refactoring and migrating existing projects to more modern stacks. These projects aren't trivial, and so we've put a lot of time and effort into making it easier for teams and organizations to bring their infrastructure into a cloud engineering world. And even if you are working on a greenfield project, but you want to steal components from another project that is maybe in ARM or whatnot, you can convert it to Pulumi and to make it a little bit easier to get things up and running. So the tools that Pulumi has built to be able to migrate from other tools into Pulumi allow for reliable import of existing cloud resources. And so these include having ARM to Pulumi, CloudFormation to Pulumi, Kubernetes CRD, custom resource to Pulumi, and Kubernetes YAML to Pulumi, and Terraform to Pulumi. And so if you are having existing workloads and need to migrate over to Pulumi, we've done a lot of work in this space that enterprises have leveraged. So now let's get into the fun part, the demo. I just want to hop into a really quick, simple demo of how to use policy as code. It really just helps us kind of visualize what we're talking about today instead of you having to take my word for it. So first things first, I'm just in a demo folder in my computer, and I'm going to do two things. I'm going to create an S3 bucket, and then I'm using a Pulumi program, and then I'm going to have a policy that essentially acts over top of that bucket. And so the first thing we're doing is creating the S3 bucket. So I'm going to make a directory called S3 bucket because I'm super original. And then from there, we're going to jump into that bucket, into that directory. And then we're going to run Pulumi new, which is how we get a template. So I'm just going to use a straight out of the box AWS Python template because I like Python. And I'm going to call it PulumiUP demo, which I already have, of course. So let's just call it demo 2. I'm happy with that description. Okay, I'm happy with this region. So while it's doing that, just a quick explanation. So we're now going to create another directory, which is just going to be a template, the exact same, the AWS Python template for policy. And then we're going to run it and see how the policy applies to the bucket. And then I'm going to change the bucket to be read public or public read the ACL. And so from there, it should block the deployment based on that. And obviously this is like a really simple but like valuable use case in that there's been tons of data breaches from people leaving their S3 buckets open. So it's very relevant, I feel, even though it's quite simple. So from here, we're making another directory, which I'm just going to call policy because once again, variable names, super original, and jump into that. And from here, we can go Pulumi policy new, and we can get the templates for policies. I'm going to grab the AWS Python one again. And so the next thing we need to do is go back to our S3 bucket directory and you can do a PulumiUP with the policy, or you can also use Pulumi preview to see what would happen. So I'm just going to do a preview so we can see. All right, so jumping back over here, Pulumi preview, and then we're going to do -- policy pack, and then the directory to what we just created. Okay, so as you'll see, we get a link of what we're creating. So we're creating a stack, right, which is called demo 2, because I named my project, my stack, the same thing, very intuitive, and then an S3 bucket, which is being created. And then as you can see, there's a policy pack being run on it, all as well. So I am gonna PulumiUP this so that we have something to see in the console. Lovely. Okay, so yes, I want to perform this action. Okay, so now I have my bucket name, it's been created, and the policy has been applied. So if we want, we can hop into this on the Pulumi service, and you can essentially see what happened, what was created. And so now we need to go into VS Code and modify our bucket to have ACL be public read. Okay, and it should be that simple. Control save, and we're gonna hop back up and I'll do a preview. So as you can see, it blocks the deployment. I'll do an up as well, just so you can see the same behavior. And it says there's this mandatory policy where you can have no public read. And so with that templated policy that we created earlier, basically this is defined. If the ACL is public read or public read write, you cannot deploy it. And there you have it. That is the magic of it all. The only other cool thing to check out is my preview of that on the Pulumi service. And so as you can see, it says the preview failed. It gives me the reason. And then I can also see the diff. So I can see that it went from being private, which was like an inherent setting, to public read. All right, I hope that put everything into context. All right, we've talked about a lot of content today in a short period of time. And so in conclusion, enterprises around the world are using the Pulumi Cloud Engineering Platform to enable innovation within their developer space, to increase the velocity at which they're releasing features, and to adopt the best security and compliance best practices. Now, I hope that you've learned something today, and I hope you had fun doing the demo with me. And most importantly, I am excited to see what you build with Pulumi. Thanks so much.